Hello, class. Today, what we're going to look at is the fundamental counting principle. So these are going to be the notes for this little section. So we're going to first start with an example problem. It says that a student can choose a computer project from one of three lists. Those lists contain 23, 15, and 19 possible projects respectively. But how many possible projects are there to choose from? So this is an or situation. So whenever you see that it's like or, we're gonna add. So what's gonna happen is we want to choose one project from the first list, or we can pick one project from the second list, or we can pick one project from the third list. So we can pick from that first list, there's 23 possible projects, or we could pick 15, or we could pick 19. So adding up all of those, we should get 23 and 15 is 38. 38 plus 19 is 57. So there are 57 possible projects to choose from for that one student. So this falls under this thing called the sum rule. The sum rule is if the first task can be done in, let's choose a different color. So we'll call it n sub 1. So if you see the letter and then that little subscript, you say n sub 1. And then a second task, we'll call it n sub 2. You're going to see a lot of subscripts in this course. If these tasks cannot be done at the same time, so that means, remember, we're doing one project, so we can't do one project and another project at the same time. We're doing one project or another one. We're going to do n sub 1 plus n sub 2. So that is how we do that one. So that's the sum rule. Then we're going to come along here to this project, or this problem. And we've got a restaurant meal consists of an appetizer, soup, or salad. We're going to combine those, an entree and a dessert. So in the menu, there's 5 appetizers we could choose from. We've got 6 choices for soup or salad, 13 entrees, and 4 desserts. We want to figure out how many different meals are possible, and we're going to select one thing from each section. So we're going to choose one appetizer, one super salad, one entree, one dessert. So we want to figure out how many different possible meals we have. So if I choose like mozzarella sticks as my appetizer, I could choose potato skins as an appetizer, or whatever it is. Those would then separate into, so there's 5 different categories for that. And then after I choose one of those, then I have the 6 choices for super salad. So as you can see, it's going to get really big really fast. So there's 5 for that first choice, and then each of those 5 choices will have 6 choices coming off of those. And then at that point, after that, there'll be 30 possible choices for just the appetizers and the super salad. And then off of that, there's going to be 13. So the way that we do this, and it's going to make our lives a little bit easier, is all we do is we just multiply. So whenever it's an and, we're going to multiply. So for the appetizers, we've got 5 choices for that. Then we're going to multiply it times the 6 choices for the super salad, and then times the 13 entrees, and then times the 4 desserts. 30 times 13 times 4. I did not do times on my calculator. All right, so that's going to be 1,560. So that's how many different options we have at that restaurant. That's how many different combinations of meal. And that's assuming that we're making a selection from each category. If we're just choosing one, so like you might go in and just choose an entree, then that's going to become an or situation, and we would have to add as well as multiply. But this problem, we're just going to keep it simple. And so we're multiply. So the product rule is if there are n sub 1 ways to do the first tab, n sub 2 ways to do the second one, then there are n sub 1 times n sub 2 ways to do the procedure. So all we're going to do is multiply if it's and if it's or, we're going to add. So there might be some times where it's a or, an and a or, so we'll just have to make sure we read the question carefully. So the next one is the EPA wants to run a campaign that will help us protect endangered species. they choose one animal for a TV commercial and one animal for a magazine ad. So there are 4 animals. We've got a cheetah, a duck-billed platypus, an eagle, and a tiger. So we want to figure out how many ways the EPA can run these combinations of these animals. And it doesn't say that we don't have to worry about repeating. So what's going to happen is we have 4 ways to choose the TV ad. I like to do this where I have like a little placeholder. So we've got the TV ad, and then we've got the magazine ad. And so we have 4 options for the TV, and we have 4 options for this. It's an and because we're going to run, if you notice here, we've got and. So we're going to multiply these two, so there's 16 ways we can run those ads. All right, now we're going to get into a little bit of computer programming stuff. So a bit is just a 1 or a 0, and then a string is just a list of those 0s and 1s. So like a bit string of a length of 7 would be like 0, 0, 1, 0, 1, 1, 0. I'm just making this off the top of my head, so I might have miscounted. I think that's 8, actually. So that's an example of one bit string of a length of 7. So what happens is we've got a 0, 1 for this first spot, 0, 1 for the second spot, 0, 1 for the third spot. So there's basically 2 options for each of those. And we're doing them in succession, so they're going to be AND situations. So we're going to be multiplying it. So it's going to be 2 times 2 times 2 times 2 times 2 times 2 times 2. I think that's 7. Or we could just say 2 to the 7th power. I wanted to do that. I believe that's 128. Just double check in my calculator. Yep. So that's going to be 128. So there's 128 different bit strings of a length of 7. So in the next question, it has it a little bit different question. It's going to put a little bit of a few restrictions, and this is just want to highlight this. It says or, so that means we're going to have to add some stuff. And one thing about this question is, so we have bit strings that are a length of 8, and they're going to start with 1 bit. So that means they're going to start with a 1, and the rest of them can be whatever they want to. Or they could end with 2 bits that are 0 and 0. So we know what the ending are for those. So there's only one choice for like the ending, or there's one choice for the beginning. But what happens is there may be an option where, let's say it starts with a 1 and it ends with 2 zeros. For all of those options, we would be double counting. So what we have to do is subtract out those that we double counted. So the way that we're going to do this is we're going to start with the 1 bit. So that would mean that there's one option to start with, and then the rest of them are 2s. So there's going to be, so let's just say we had 8 spots. So 8 spots in the string, 1, 2, 4, 5, 6, 7, 8. So in this first one, it has to be a 1. In the second one, it's either a 0 or a 1. The next one is a 0 or a 1, and then so on and so forth. So that means that there's 2 options for this one, 2, 2, 2, 2, 2, and 2. Those are all AND, so we would multiply that one. So that would be 2 to the 7th power, which we know is 128. The other one is that it could end with 0, 0. So that means that we have our 8 spots again. Yep. But over here, then we have, it's either that 0 or the 0. So there's only one option for each of those. So I'm going to put up here, that was a 1. So there's only one option. This one, we know that it's a 0 or 0. These other ones, we have 2 options because it could be 0 or 1 here, 0, 1 here. So there's 2 options, 2 options, 2 options, 2 options, 2 options. So we multiply all those together. So that's going to be 2 to the 6th power, which is going to be 64. And so we get this word or, so that means we would normally add those 2. But there's one thing that we do have to worry about, and that is the AND situation. So that is if we started with a 1 and we end with 0, 0, So that would mean that we would have our 8 spots, 1, 2, 3, 4, 5, 6, 7, 8. We'd have one option for the start. We got 2, 2, 2, 2, 2, and then 1 and 1. So that's going to give us 2 to the 5th power, which is 32. And so those are all the ways that it would start with 1 and end in 00. And those are double counted here. So all of those options are here in this option and in here in this option. So what we have to do is we're going to add these two. So we're going to add the 128, add the 64, and then subtract the 32. So if we do that, 32, so that's going to be 160. So you just have to be aware, make sure you're not double counting stuff. Yeah. All right, and the last one is going to fall under this thing called a tree. I'm going to try and do it really quick so that, so basically we have a playoff. 2 teams consist of at most 5 games. The team that wins 3 games wins the playoff. So what we're going to do, we're going to make a tree that kind of represents the situation. All the stuff that we did above can also be represented as a tree. So what's going to happen is we go and we kind of make a tree. So think of that first game. This is the first game column. Team 1, I'm going to just call it Team 1 and Team 2. So let's say Team 1 won the first one, or Team 2 can win that first one. And then what will happen is off of this branch, there'll become 2 options. Either Team 1 would win or Team 2 would win. And then here we have Team 1 or Team 2. Now remember, we're playing a best of 5, which means the team that wins 3 games is done. So what happens is this team right here has won the playoff series because they've won 3 games in a row. They won the first game, they won the second game, and they won the third game. But if the T2 wins it all, then we would have to go, we go T1, and then this would be T2. And so now at this point, this ending right here, it would take 4 games, but Team 1 would win that one. Or there's an option here, Team 1 could win there, or Team 2. And then, so Team 1 won here, but Team 2 won this one because they won 3 in a row. Sorry. Wait, let me make sure. 1, 2, 3, 4, 5. Yep. Okay. So the 5 games. So Team 1 won the first 2 games, and then Team 2 won the next 3, or Team 1, then Team 2, Team. So you guys, I think, get the picture. I'm just going to make the rest of the. So Team 1, Team 2. I might be running out of room because I did not plan well enough. So that would mean that, and then here. So Team 1 won there, and then so Team 1, Team 2. Here we got Team 1, Team 2. Probably should have put those in different order. So yeah. I believe that gives me, yep, because that would be Team 2. So if I'm doing Team 2 won here, Team 2 won here, and Team 2 won here. And then Team 1 won here, and they won there. And then we basically do the same thing for the bottom. It'd just be Team 2 and keep on going. I'm not going to keep writing it out, but I feel like I missed one. Because it should be 5 and 5. Oh, no. Sorry. Yeah, Team 1 wins here. So they win 6, but Team 1 only wins 6 or 4 in the bottom one. So what should happen is there's 10 ways for Team 1 to win and 10 ways for Team 2 to win. But down here, if I were to redraw this, it would basically be the reverse of this. Team 2 would win 6 ways, and Team 1 would win 4 ways. So if you think about it, it kind of gives you a better chance if you win that first game, because if you win that first game, you have 6 ways to win. If you lose the first game, you only have 4 ways to win. But yeah, so that's everything for the fundamental counting principle.